As you know, when you cast it apart, remember when we did castings? The thing is in the blueprint, everything had name. For example, this one's called a flange, like this one's called what? Kind of bore, and these holes, and those in here, clearance holes. And the bolt circle is set. The bolt circle is a line that set them, but they are called clearance holes. And that one's? What about tap holes? Because they got thread, right? So tap holes, clearance holes, bore, kind of bore, flange, is that right? This one probably is an undercut right here. See that little cut right there? Same here. This one, dovetail slab, is that right? This one is a hole, is that right? A bore hole probably that goes into rim holes. I don't know what exactly they use for doing that. Had to see in the operations. And they got spot face. A spot face is a shallow kind of bore. The tool only cut maximum 30 to 60 thousandths. And a spot face with the purpose to create a flat surface that we can set another connection here. If it's a kind of bore, it's too high the head of the screw, or to produce a very deep enlarge of the hole. But spot face is only to clean the surface. As you notice, the surface is not even right there. Go like this, and they put the spot face. That one is a slab holes. This form right here, when they create an casting part, the walls of the casting piece are very thin, very light pieces. As you can see, casting is with the purpose to save material, elaboration on the part. The part is very light. You can see right here, those are casting pieces, many casting parts. But in order to produce more rigidity on the surface, they create that. This in here is called a rib or a web. Web is when it goes like that, right? For example, right here, right? See? Or a rib. But if they put in holes right here, they don't have enough material to put the threads. So they pour more material, and then after that, they gotta face the surface of those holes. When the material is poured around the holes, it's called boss. B-O-S. Is that right? Boss. When the material have another shape, all the way down round, for example, slats, or they can have multiple holes, it's called a pad. Is that right? Mm-hmm. Pad and boss. They both do with the same principle. The principle to create a raise up of the surface to create more meat on the part. That way they can put the holes on it and maintain rigidity. Does that make sense? Boss and boss. So that's described in your book on page 155, as you can see it right there. Now, we're going to talk about slab holes. Okay, this one right here, it's called a square hole, right? A square hole with fillets around, right? We got fillets around, big fillets, right? A square hole with fillets, right? Mm-hmm. Already, this one's called a slab holes. And remember, this one's called what?
Hub.
Hub. And that one?
Flange.
Flange. And this? That one is a square hole. Is that right? And in here, what do we have right there?
Those are
It's deep.
thread holes.
There you go. Thread holes. Thread holes? Yes, thread holes. Tap holes.
Tap holes. Like
Is that right?
Yeah.
Yeah, perfect. Is that right? And what about those in here? Those four.
Those for
The four little holes around there.
tap holes too. Right?
Tap holes too. And there are four. Are they in the ball circle? Yes, they are. Mm-hmm. Even though you don't see it, but they're in the ball circle. And how they get from here to here, they create a triangle, and then X and Y, and the machine goes in there. What triangle they create? A right triangle. And we want to practice that part, is that right? So by talking about the slab holes, and the slab holes, around the slab hole, we have like a spot holes, is that right? Because it's not a kind of board. A spot hole is a shallow, 30 to 60,000, with the purpose to create a flat surface that way they firmly set the part, or you put the watch and stuff like that. Well, slab holes are dimensioned in three different ways. They can be dimensioning by width, and the distance between center. There are two dimensions right there. So the third dimension, which is the whole width of the slot hole, is not given. You have to calculate it. The thing is, in a print, they never give you a dimension that is completely two times. They can give you the same dimension on part. It's like your paycheck. You got your paycheck, they can pay you the whole paycheck, or say, okay, you know what? I want to pay you half this weekend and half the other weekend. It's the same. Same here. Dimensions, this dimension right here is not given. You have to calculate it. So you have to add the tolerance in both of them, so this one accumulates tolerance. Is that what I'm saying? How many tolerance they accumulate in here? 2. By the way, it's in page 155. Or 55, yeah.
Yeah.
Now, in here, they have used a different form of dimension. Can you notice? Yes or no? Here, they give you, instead to give you the whole width of the part, I call them diameter. Because this is a slot hole, it's right here, and you extend it. And this is the diameter. Does that make sense? But they don't give you diameter. What they give you? Radius. Yes or no? And then the radius is only one time in one side. But you know it's typical. Another radius right here. Yes or no?
Yeah.
And then they also give you the distance between centers. So when you want to find, because remember, you always have to calculate this dimension, this dimension. When you calculate these dimensions, the tolerance will be accumulated. How many tolerance accumulates on a slot hole dimension by the radii and distance between centers? 2 or 3?
3.
3. Is that right? Yes. When the dimension is by the radii, they accumulate 3 tolerances. Does that make sense? When dimension by diameter or width, 2 tolerances. In both of them, they accumulate tolerance. It will be a chance that the part is so precise that they don't want to accumulate tolerance on it, right? For that, they use that form. Remember, we don't do the part up to this point. The drafter do it, the designer, and we just made it. We gotta make the right interpretation of the part. And as you're an inspector, you have to inspecting the part and checking the part to see if it's right. Well, in here, they don't give you the distance between center. So if you want to make the part, you have to calculate the distance between center. Yes or no?
Yes.
So you have to go from half of that from here and half of that from there. Put the first holes and then the second one, and then with the end mill connecting them. Does that make sense? Or you can use a smaller end mill, plunge it, and then find them, and then after that get larger end mill, same size to get diameter. That makes sense? On a CNC it's different. On the CNC you put it, click, bam, and you cut a packet. There is a CAM cycle that they got all the parameters for the type of packet that you want to cut. And then you configure what is the shape of the part, and you do that packet. Guess what? When you go to Mount Ford, you want to do a packet on a CNC using an end mill. Is that right? The program have a GAN cycle, and you gotta type well, they probably give you the program, but you gotta study what is point to point, where the end mill had to go to cut that packet. And then you have to get the coded compensations. You go to the left or to the right, that way you cut the right sides of the part. Does that make sense? And here, what we're going to learn is this is a slot holes. What form of dimensioning they use for that one? If you look at the part, dimension can be set, or tolerance can be set in different forms. Can be set global with plus and minus tolerance. They can call also plus and minus bilateral or unilaterals, or they can give you limits. What is the limit dimension? How much will be the tolerance in these slab holes on the width?
Is it 2000s?
2000?
Plus on the width?
Let's see on the, this is the width, right?
Yeah, so it would be 1000, right?
1000.
Yeah.
Is that right? But this one is the total tolerance because, as you know, tolerance is equal to maximum minus minimum limit, right?
Mm-hmm.
So therefore, that would be, in that case, 876 minus 875. So that results on 1000. I want to make it bilateral. What do I have to do? To make bilateral, make it, let's see, plus and minus bilateral. Number one, I had to divide the tolerance by 2 and add the plus and minus symbols. So therefore, this one would be plus and minus what? Plus and minus what?
5/10.
5/10. And then you have to find the mean dimension. What is the mean dimension, the midpoint between those two? How you do the mean dimension? Adding them and divided by 2, or just adding the minimum to the lower limit? If I add 5/10 in here, so how much would be?
875
And 5/10.
plus 5/10.
Exactly. So the mean dimension will be maximum limit plus minimum limit and then divided by 2, right? So therefore that would be 0.875 and 5/10. Yes or no?
Yeah.
And then I have to assign what?
That's right.
Plus and minus what?
5/10.
5/10. And then I want to find the maximum limit again to see if I did right. 875 and 5/10 plus 5/10 is 876. Yes or no?
Yeah.
And 875 minus and 5/10 minus 5/10 is 875. Yes or no?
Yeah.
Boom. Everything is right. See? So this type of exercise, we will follow you at the rest of the class right now, because there will be a bunch of exercise that we have to solve like that. You have to find the mean dimension, or you have to calculate using limits. This one is limit. Limit is shown print when the dimensions are very precise. Is that right? When the dimensions have more tolerance, they show plus and minus, as we see before. Does that make sense? Plus and minus can be specific or unspecific. When it's a global, the tolerance is given in a tolerance box. When it's a specific, it's shown in a print area. Is that right? And it can be bilateral or unilaterals. And you know that part. Bilateral is when the amount variation plus and minus are the same. And unilateral is when they are not the same. They can be -2 or +10 like a drill. Is that right? Or they can be 0 to +2 like a board. Or they can be 0 -3. But those are unilateral. All right. So, how much is the tolerance in here? On the overall length?
2.
2000. If I want to make it this bilateral, what I do? Point,
Divide by 2.
But this one is very easy. I divide 1000 by 2, it's 1, and that would be what? 76, and plus minus what?
One.
1,000. Simple. Is that right? Perfect, 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 perfect. One, two. So we go with this first part here, and this one, that's what we have right now. Is that right? Slab holes, casting dimensions, standard tapers. Let's go see what it says. Let's say on casting dimensions, okay guys? Can you read that part? Let me see. Louis, you wanna read it? You will read it?
Dimensions found on casting drawings will usually be held to 2 places. Decimal inch system, except for machine hole sizes for dimensions between finished surfaces, which are usually held to 3 or more places for close tolerance control. Note the symbol. What's the number? The symbol?
Okay, let me see, which one?
It's like a
Yeah, forget about the symbol, is not showing there. That's the symbol for fins. Note the symbol is used for center. Is symbol, that symbol is used, that's not the symbol that is just put something in there. It's used from the left side of the view to indicate symmetry. The symbol of symmetry is this, in the center lines, for example, is the symmetry. They put CL. Or they can use this. One of those ones. Alright? Symmetry is this symbol. On the print, they put that, just like that. From the center line, symmetric. If you go on your book on page 260, you will notice what is the symbol of symmetry. Page 260 in the book. You know what? They don't show that one. I'm glad I give you the handout, but I want to refer you to page 356, 357. On your book, 356. On page 356, you will have, I think by the middle of the chart, the word symmetry and the symbol next to it. 356. Take those notes. And when you know with the symbols, you can find them. Symbol for, according to the American Standards Mechanical Engineers, is that right? That's our symbols. According to the Y14.5 regulations. On ISO. You understand that? So that symbol in there, you can fix it and put something like this. It's like that. Sometimes on a plane, about the center line, they also can show those two, and we see that before. One is symmetry about the center lines. Okay? All right, gentlemen. So, what else you read for casting, Louis? And thereby reduce the number of dimensions to calculate is required. Also observe that the 2.500 radius does not require location dimension because it's wrong tangent to the radii. Okay, so yeah, they refer about that part, and that part is on page 156. So, what is, let's go review this part quickly. What is the name of the part?
Adjustable bracket.
Adjustable brackets, is that right? All right. What is the diameter of the boss?
Uh-huh.
It's 625,000.
The boss, diameter of the boss. So if I look, I have the part here. Look at this one, guys. How do you call this? Boss. This one? Boss 3. Is that right? Those are boss. So on the casting, this one? How do you call this one?
The pad?
Boss.
Or the bar?
Right?
Pads
Boss,
are,
right?
Pads are long.
That had to be any other shape that is not round.
Okay.
That's it, simple. Is that right? So here, in your part, in front of you, what is the diameter of the box?
It's 625,000.
Are you sure? 625,000 is the hole in here. Is that right? Yes or no?
Yeah.
And that hole is called borehole, right? Yes or no?
Yeah.
Is that right?
So 625,000 plus.
No. Keep going. Yeah, you can plus whatever you wanted.
Oh, 1 inch
Exactly. Where do you find that?
on the side.
What side view? The left or the right?
Oh yeah, there it is. On the right. On the left.
Exactly. In the right side view, my part is right here. Luis, is that right?
Yeah.
I'll flip it right here. And this one right there, this is the box that I need to know how much it is.
1 inch.
1 inch. How much is the tolerance?
10,000.
10,000 or plus minus 10,000?
Plus or minus 10,000.
Excellent. Plus or minus 10,000. Yes. Is that tolerance a global or a specific? Or a specified?
Global.
Global or unspecified. Does that make sense? You find the tolerance right here. Every time you see the part, and that tolerance is restricted by the number of decimal places after the zeros after decimal places. Yes or no? If it's 2 decimal places, then we have it here plus minus 10. If it's 2 decimal places, it'll be plus minus 5. Any dimension that do not is specified on the print, tolerance will be right here. But one dimension are important. Actually, how much is diameter of the borehole on the bus?
5/10. Oh.
Diameter.
Oh, the diameter is 625.
625. And how much is the tolerance?
5/10 plus 5/10 minus
Yeah,
0.
Plus 510. Oh, 510. 510 is okay. Or you could say minus 0 plus 510, then you specifically said how much direction they take it. Does that make sense?
Yes.
Actually, if you see that, if you want to talk about the fixture, you have to say, okay, it's 625 or 58 minus nothing plus 5/10. Does that make sense?
Yeah, it makes sense. Yeah.
Plus 5/10. If we want to make this bilateral, what do we have to do? Divide this by 2. Is that right?
Yep.
So I want to make it quickly bilateral, that way you know that. But you could do it in your notebook right there. Make it bilateral, that way we practice a little bit that part. So I want to make it quickly right here on the board. And let's see who finish fast. Okay? So I want to go right here. I want to put that point. And I want to go, okay, 6, 2, and this is 510. So not affecting me at all here. So this divided by 2, that would be 210 and 50 millions. So 210 and 50 millions. All right? Plus minus 0.000 210 and 50 million. Yes, that's bilateral. Yes or no?
Yep.
Okay? Boom. Okay, look at, they don't give you location of this radii because that's the casting part. This part, those two are tangent. You get a hole that is exactly 150,000, you bring it over here, a circle, when they touch it here and they touch it there, boom, the part is done. Does that make sense? So let me see one more question. How much is the width of the slat holes? How much is this width? The width of the slat holes?
What question?
Look, how much is the width of the slat holes? Like how much is diameter of the slat hole? Bah. How much is diameter of the slat holes?
Is it
531.
531,000. Yes. And how much is the tolerance?
Plus or minus 5, 6?
Plus or minus
No, 5,000.
5,000. Well, this one,
how come yours doesn't have like the other number on it?
other number.
The 1.40,000.
I don't have this, huh? This one? But this is on the
No,
back.
on the middle, right
On
next,
the
yeah,
middle?
right there, that right there. You just touched it.
Yeah, this one?
Up more, on the middle, yeah,
Here?
right there. That one. There's a
But they extend that right here, right?
yeah. They
The
extend it.
arrowhead, right?
Yeah,
And then they put the arrowhead right here, right? Something
Yeah.
like that?
yeah.
And they put the number here, how much?
1 inch,
Let me look at my
240,000.
print. Oh, yeah. They put like this, man. Arrowhead, and they specify here 1 inch, 240,000, and this one is plus minus 10. Yes or no?
And that's the pad, right?
Exactly.
That's the pad, yeah.
That's the path. Is that right?
Yep. That makes sense, yeah.
That's the path. And this one, I say diameter of the slat hole,
Yeah.
which is like
Which
that,
is there, yeah.
is 5 inch or width, right? How much is the overall length of the slat hole?
I would think it's
See, slat holes. Can you calculate that on your notebook? So that would be equal to what? Distance between centers? Plus slat diameter or width. So, the distance between there would be how much?
2 inches.
2 inches, plus minus what?
5.
Plus minus 5,000. How much is the width of the slat holes?
All 531,000.
531,000. Plus minus what?
5,000.
5,000. Now, I have those two, and I have 2 inch, 531,000, plus minus what? Plus minus what?
5,000.
Plus 5,000 here, right? 5,000 here, and 5,000 here. That would be plus minus what?
10,000.
10,000. How much is the maximum? Maximum.
2 inch and 541,000.
2 inch, 541,000. And the minimum?
2 inch, 521,000.
2 inch, 521,000. 21,000? Yes. And because we got plus minus 5, 35, yeah, like that. Do you guys understand that? Okay. Should I put down notes and the notes you don't see it? More clear?
Good.
The note on the board?
Yeah, that's good.
You good?
Yeah.
All right. So, can I erase it?
Mm-hmm.
How much is the surface roughness on the path? How much is the average surface roughness on the path?
Is it 32?
32 what? It's 32, yes. 32 what?
Is it millions?
Millions. 0, 0, 0, 0, 4, 3, 2, 6 inches. This is the roughness average as decimal, expressed as a decimal form. All right? 32 is micro inches. That symbol stands for millions. Does that make sense? How much is the roughness on the bus?
63 million.
63 millions. What surface is smoother? The face on the bus or the face on a pot? What surface is smoother? The face on the bus or the face on the pot? The face on the bus or the face on the pot?
On the pad.
On the pot. Right, because this number is smaller, all right? How much are the fillets? Fillets are this part right there, right? Fillet, 120,000. Yes, plus minus 10, yes? How much are the rounds?
So, is it 0.60?
60,000. 600, 0.60? 0.60? We say 0.60.
60,000.
60,000 is not 0.60. 0.60 is 600, right?
Yeah.
I'm sorry, don't say 0.60, confusing. Say 60,000. Does that make sense? Oh, yeah. Don't even say 0.06. So 60,000. Let's go check in the shop. Okay, guys. So, what do you think if you answer that pretty quickly now and then we review it to see what you can write? Is that right? Everybody open your calculator. We do like a quiz right now. We answer that pretty like we go with a quiz. And then when you finish, I review all of them.